Hi, my name is Nathaniel. This is a video on the trigonometric derivatives. They're really important in math, so let's get right into them. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cosecant is negative cosecant times cotangent. The derivative of secant is secant times tangent. And the derivative of cotangent is negative cosecant squared. So for our first example, we have the derivative of 2 sine. So first we'll take the constant 2 and we'll factor it out. So we'll have just the derivative of sine, and the derivative of sine is cosine, so that leaves us with our final answer, 2 cosine. For the next two examples, it's going to be really helpful to be familiar with the chain rule and the power rule. For our second problem, we have negative 3 times cosine of x squared plus 2. First, I'll factor out negative 3, which leaves me with negative 3 times the derivative of cosine of x squared plus 2. Okay. Since I have a function x squared plus 2 inside of cosine, another function, I'm going to have to use the chain rule. And it's going to be really helpful for me to just set x squared plus 2 equal to a variable u. This will make doing the chain rule much easier. I'm only going to use this variable when it's inside of cosine. So we have negative 3 times the derivative in terms of u of cosine of u multiplied by the derivative of x squared plus 2 in terms of x. Okay? So negative 3 times the derivative of cosine, this is negative sine, so times negative sine of u, and the derivative of x squared plus 2 is 2x, so times 2x. So now I'm going to take these constants out. So I have negative 3, negative 1, and 2. I'm going to factor all of them out. And negative 3 is already factored out. So I'll factor out the x as well. So the final answer is 6x times the derivative, times sine of u, and our final answer, I'll plug the u back in, which leaves me with 6x times sine of x squared plus 2. And I'll put this in parentheses, or in brackets, excuse me. For our final example, we have the derivative of negative secant of cotangent of 5x. So first, we'll factor out the negative 1 to get negative 1 times the derivative of secant of cotangent of 5x. Once again, we're dealing with a composition of functions, so we're going to have to use the chain rule. So I'll set cotangent of 5x equal to u. The chain rule will be used twice in this example. So now, we have negative 1 times the derivative in terms of u of secant of u multiplied by the derivative of cotangent of 5x in terms of x. Okay, and I'll consider the second application of the chain rule later in this problem. So we have negative 1 times the derivative of secant, which is secant times tangent. So secant of u times tangent of u. And the derivative of cotangent in terms of x. So now let's do the second application of the chain rule. So I'll set 5x equal to v, and this is because 5x is a function and cotangent is a function. We use the chain rule whenever we're dealing with a function inside of a function. So 5x is equal to v, and we'll take the derivative of cotangent of 5x in terms of v. So cotangent, the derivative of, in terms of v, 5x, or cotangent of v, excuse me. Multiplied by the derivative of 5x in terms of x. So our u is equal to cotangent of 5x and v is equal to 5x. Okay, so our problem, now we have negative 1 times secant of u times tangent of u. The derivative of cotangent is negative cosecant squared. So we have tangent of u multiplied by negative cosecant squared of v, and the derivative of 5x is just 5. So multiplied by 5. So now we're going to factor out our constants. Our -1 is already factored out. So we have our negative in front of cosecant squared and our 5. So when factored out, this gives us 5 times secant of u, and I'll go ahead and plug u back in, so u is equal to cotangent of 5x. So 5 times secant of cotangent of 5x times tangent of cotangent of 5x times negative cosecant, or excuse me, just cosecant. I'll write it down here. Times cosecant squared of 5x So if we reorganize the final answer so that the highest power cosecant squared is first, we'll have 5 times secant, or excuse me, cosecant squared of 5x times secant of cotangent of 5x times tangent of cotangent of 5x. And this should be brackets and these parentheses. Thank you all for watching. I hope that this was helpful. Have a great day.